And water treatment. Engineer Ahmed is currently working at NP Company Egypt. He has a BS degree in chemical engineering from Cairo University in Egypt. And now Engineer Ahmed will conduct a technical session. So Engineer Ahmed, the stage is yours. Please share your screen.
Hello everyone. Today we are going to give a session about NGL fractionation process. So let's start sharing the presentation. NGL fractionation process. As we know, the typical component of the natural gas mainly consists of the following impurities like hydrogen sulfide, carbon dioxide, water that exists in water in vapor phase, methane, ethane, propane, butane, and all hydrocarbon. Actually, this hydrocarbon are not the only hydrocarbons that exist in the natural gas, but they are the main. There are some important definitions we shall know at this course. The first is the LNG, which is an abbreviation of liquefied natural gas that mainly consists of methane. Then NGL, it's a natural gas liquids that consists of ethane, hydrocarbon, and the heavier components. And LPG. LPG is abbreviation of liquefied petroleum gas that mainly consists of propane and butane. Natural gas main processing stages. As we know, when natural gas is extracted from the field, it's going to be purified to remove sands and any solid. Then sweetening stage that remove any impurities from the natural gas like hydrogen sulfide and CO2 and so on. Then dehydration. Dehydration is to remove water from the gas to prevent the formation of hydrate in the pipeline or any equipment. Then natural gas recovery. Actually, natural gas recovery is to recover C2 plus and heavier components. We're introduced to the main process we will talk about today is NGL fractionation. NGL fractionation is to recover ethane, LPG, butane, and condensate, and so on, separately. The following figure is an illustration and very simple brief for the process. As we know, the recovered NGL is introduced to the de-ethanizer to recover ethane from the top, and we obtain C3 plus from the bottom that introduced to the de-propanizer. From the de-propanizer, we can obtain and recover propane and LPG, and from the top we obtain C4 plus. C4 plus is introduced to the de-ethanizer to obtain butane from the overhead, and C5 plus from the bottom. It's just a very simple figure. Today we will give a case study extracted from Aspen HYSYS. Today we will build this typical configuration of NGL fractionation process. As we know, the main equipment in this process is de-ethanizer and the de-ethanizer, de-propanizer, and de-butanizer that will do a process on the recovered natural gas liquid. At our session today, we have two feeds that we will do a process on them. We have two feed streams, feed number 1 and feed number 2. Okay, let's start to model this streams on the HYSYS. To save our time, I entered the fraction of this component at these two streams. Okay, And now we will build the process. The first requirement we will add in this process is de-ethanizer. From de-ethanizer here, we can drop a distillation column, which is a typical distillation. We can add energy stream to the distillation column. As you know, it's the typical interface for the HYSYS. Okay, and this palette is to enter the information you have in the process. The data I will enter in this program, I will share it with you after the ending of the session, inshallah. Okay. As you know, at the distillation, we shall introduce feed streams and energy streams. Energy streams will be as the following. We shall add energy stream. We name it as EX duty with a heat flow 2.1 E per 6. Okay. Then we will open the distillation column. We will name it DC1 as a de-ethanizer to extract C1, and the feed are feed 1 and feed 2 and duty. We will introduce feed 1 at tray number 2, and feed 2 will introduce it at tray number 4. Okay. Then as we know, the number of stages in de-ethanizer.
Excuse me, Engineer Ahmed, if you are working in the software, so we are not able to see your screen. I think you need to stop sharing the presentation and start again sharing your software.
Okay.
We have another option to start sharing the screen itself, and at that time you will be able to share everything. Okay, that's great now.
Okay, can you see that? Excuse me.
Yes.
Okay.
I hope you can start again because we were not able to see anything from beginning.
Okay. Let's start. As you said, the simulation will be conducted on two feeds. Okay, I introduced the composition of two feeds here to save the time, and we will start by doing a process on these streams. Okay, first we will introduce a separator, which is a de-ethanizer. De-ethanizer like that. Typical distillation column. Okay. We will open it, and it is a typical palette of the column. We will name it as a DC1. DC1. Okay. Then we will end streams here. Stream number 1 in stage number 2 and stream number 2 in the stage number 4. Okay. At de-ethanizer we will use 10 stages, and we will choose it as a total condenser. The overhead, which is methane, will be DC1 overhead, and at the bottom will be DC1 bottom. Okay. As we know, we need energy streams for the condenser and the boiler. Okay, for the condenser and the boiler, we will use condenser DC1, the boiler. Okay, and DC1 condenser. At the next page, we will use one through distillation. Okay, then at the top pressure, we can use the pressure will be at condenser 2275 kilopascal, and the boiler pressure will be 231 kilopascal. At the next, it's an optional data we can give. We will give just estimate temperature that will be negative 88 degrees Celsius, and the boiler will be 27 degrees Celsius. Then we will be choose done at the bed. Okay. If you can see. Okay. We should give a specification for the tower. If you try to run this tower and recover this distillation, it will give you an error like that because it's underspecified. You have two data to give for this. We can go for monitor and get reflux ratio and overhead product and so on. For example, reflux ratio, we say, for example, 1. Okay. And this will be 2. Okay, as you know. Excuse me, as there's a technical issue with this palette, I will open another one. Yes. As you see, this model, I just built it before the entering the course. Okay. Yes. Yes. The data I entered is to give feed one number 2 to the de-ethanizer. We will scan see it. To solve this distillation column, we should give specs to it to be covered, and to be the degrees of freedom will be 0. I give a spec like C1 and overhead is that doesn't exceed 86% in the overhead. So I run the column and it's recovered. Then the overhead is stream. As you can see, it's the vapor phase and temperature is 87 degrees Celsius, and it's mainly consists of methane. Okay. From the bottom, the list of components are delivered as a liquid phase. Then its pressure is raised by a pump. Okay, as the following. The bottom of the de-ethanizer is introduced to the pump, then its pressure is raised. Okay. To solve the pump, you should give a differential pressure or pressure ratio, but instead we introduce the pressure that we need to introduce to the de-ethanizer. As you see, it's 2,790 kilopascal. The pressure from the pump is raised, and uh, this stream is introduced to the de-ethanizer. As we can see at the composition, it's mainly from ethane and heavier component, and the lighter component does not exist in this stream mainly. Then we used a partial condenser at the de-ethanizer. At the de-ethanizer, we did the same steps as the de-ethanizer. We give a number of stages as 14, and we choose it as a partial condenser. Okay, and we give a spec. As we know, to solve any distillation column, you should recover and make a degrees of freedom to be 0. So at the partial condenser distillation, you have 3 information to give. At this case, we give a reflux ratio, which is 2.5, okay, and the distillate rate, which is the overhead from the distillation column, we give it to be 0 in this case. Then we can give a spec, okay, from the head. To give a spec of a distillation column, you should give its name as a name, and the stage you should recover the spec. Then you give the ratio from 2 components you need. For example, under distillation, we need the ratio of C2 and C3 to be 0.01. So we choose ethane and propane, and the ratio of them to be 0.001. Okay. Then the tower is recovered by pressing the run button. Okay, like that. And as we see, it is a green bar. It means it is a recovered tower. Okay. At the next step, we obtain the bottom from the de-ethanizer and reduced its pressure by giving a valve. Okay. We used this valve to reduce the pressure. As we know, a valve can reduce the pressure by introducing high pressure stream, then define pressure drop of the valve, okay, giving a delta B. But in this case, we choose to give the pressure we want it to be introduced to the de-ethanizer. This value is given to the outlet of the valve and the inlet of the de-ethanizer. Okay, stream introduced to the de-ethanizer. Here is the specification of it. As we see, mainly consists from propane, mainly, and butane. So the function of de-ethanizer is to get all propane, mainly from the overhead, and recover butane from the bottom. So we choose it as a total condenser de-ethanizer. Okay. As the previous distillation, we should give a number of trays, as we say, 24, and choose the feed and the tray we shall introduce to the distillation. We choose tray number 11 and give the pressure of the distillation at the condenser and the boiler, and give a pressure drop to each of them. Okay. Also, to recover this distillation, we should know 2 informations. to make degrees of freedom to be 0. At this distillation, at the de-ethanizer, we choose the reflux ratio to be 1, okay, and the distillate rate from the overhead to be 110 kilogram more per hour, okay. Then we run the distillation, and the distillation is recovered. This is a simple description of the processing, but I know I should build this model in front of you, but I have technical issue. So if anyone have any question about this model, I can answer it now. Okay. Is anyone have any question? Hello, can you hear me?
Engineer Ahmed, yes, we all can hear you, but for the participants, as a webinar account from Zoom, you don't have the option to open your mic. Okay?
Okay, okay,
We only the panelist and you who have the option. Anyone else cannot open the mic.
okay. It appears no one have a question now.
If
Waiting.
they have any questions, they can drop it in the Q&A section, and at the end, by the end of the webinar, we can you can answer them.
Okay. Um, no question is delivered yet.
Engineer Ahmed, have you ended your presentation or not yet?
I have ended it. Okay.
Okay.
But I gave a time for the questions to answer it more, because I should give an information that building this model is takes a lot of time. Okay, but I built it already before the session and describe it briefly, and gave the time to the participant to give answer to them.
Okay. So, if anyone please have any question, can you please drop it in the Q&A section?
I have one question. Hello, dear. This question from Rola. How do you specify the inlet feed at which tray? Okay. At any distillation column, to specify the inlet feed, for example, at the methanizer, we choose from this palette streams that introduce to the distillation, and I choose feed number 2 and feed number 1, and you choose from here in the stage you want to drop your feed to it. Okay, this is the answer of the question.
Okay, there's another question saying that
Okay, yes,
these
from
steps are always
Salam
the
message.
same.
Okay.
Uh,
Language. Yes, from I understand, you asked about the steps of the distillation building. Yes, any distillation column follows the same steps. The only data you change is choosing the total condenser or partial condenser and no condenser. The specs of the distillation itself, as ratios you want, any fractions of specific component you want. That's it. Okay.
so, any questions?
Okay. Any question? Yes, there's a question from Lola. Excuse me, I need to choose if tray number 11 or tray in reality. Okay, to choose your tray uh, before building this model, you should do an exercise like shortcut method. As you know, there is many theoretical ways to do it by Maccabi-Tila or Gonton Savary. To choose the optimum tray, you should enter your field to it. But this case we built today is previously identified and identify the trace we introduce the fee to it. Okay. Uh, so imagine most include which parameters need to recover to coverage a distillation column and how many variables input are needed. Okay. When you build a distillation column, for example here, for example at de-ethanizer, as you see de-ethanizer doesn't have a condenser, it's just a reboiler. So you just need one data to make a degrees of freedom to be zero. Yeah, let's see that. If you unmarket this data, you will see the distillation degrees of freedom is one. So you should give one information to it. So I choose the spec of methane as overhead to be 96%. So the degrees of freedom become zero and the tower is covered. Okay. Uh, I have another example at de-ethanizer. Okay, we have partial condenser and reboiler. So we have 3 degrees of freedom we should know. As a rule of thumb, if you have number of streams out from the distillation, okay, the degrees of freedom will be the same number. For example, we have 3 streams here out of the distillation, so we should know 3 information data to the tower. If we unmark this data, so you will see degrees of freedom is 3. So we need 3 information to solve the distillation. So if we mark it, okay, and the other behavior components can be distilled with other models too. What are the models for the component of hydrocarbon? I can understand this question. Can you explain it or clarify this question, please, Dr. Abdel Hafiz? Roland, dear Karim, for example. Okay, thank you. Any questions?
Does anyone please have any question?
There is no foaming is caused at this process. This model can be used for other hydrocarbon too, except from 1 to C3. Yes, this model can be used. Dr. Abdulhafiz, any distillation column can use to fractionate any hydrocarbon, not just the mentioned hydrocarbon in this model. As I said, the hydrocarbon components we used in this model is just for illustration the NGL fractionation process. In real case, there is many hydrocarbons also.
Okay.
Any questions?
In this meantime, I will send you a feedback form in the chat. Please, everyone, make sure to fill this form so we can always meet your needs. And if anyone please have more questions, don't hesitate to drop it in the chat. Okay, Engineer Ahmed, we have 2 more questions. The first question is for Dr. Rami Harkus. In real case, there is 0% methane in DC1.
In a real case, there is 0% methane in DC1. No, DC1 you recover methane from the overhead. Mainly methane will be recovered. As you see, let's see that at feed 1, the composition, there's a methane here. Okay, as overhead, most of methane is extracted here, and if we see the bottom, methane doesn't exist at the bottom of the tower. De-ethanizer merely extract all methane to the overhead. Okay. Osama Barka. Hello, sir. Name of program that you use, please. It's Aspen HYSYS version 10. Rola, this is button. Yes. As you said, Rola, methane doesn't exist in the bottom of the demethanizer. Think are you going to no certificate for this webinar, as Jad and Abdurrahman said. The certificate will be available for the course of HYSYS.
Unfortunately, Engineer Ahmed, we
For
deliver
today,
a certificate for webinars also, but it is just a certificate of attending this webinar. So yes, certificates will be sent for this webinar also.
okay.
Okay, so thank you everyone for attending today. Uh, Thank you, Engineer Ahmed, for your great time and for this webinar. Also, please make sure again to fill the feedback form that I shared with you on the chat, so we can also every time deliver the best that you need, and we can fulfill your needs. So thank you everyone for attending today's webinar, and thank you, Engineer Ahmed, again.